Okay, let's try 11.68. The light energy that falls on a square meter of ground over the course of a typical sunny day is about 20 megajoules. The average rate of electric energy consumption in one house is 1 kilowatt. A, on average, how much energy does one household use during a 24-hour day? Okay, so from the problem, let's do problem A first, part A. We know that the energy consumption in one house is 1 kilowatt. And so that's the same thing as 1 times 10 to the third. That's the kilo. Joules per second. So a watt, remember, is just a joule per second. And so we just want to convert this, we just essentially want us to convert this from joules per second to joules per day. And so we know that there are 3,600 seconds in 1 hour. And so the seconds are going to cancel out, we're left with joules per hour. And then we know that there are 24 hours in 1 day. And so the hour is going to cancel out, and we're left with joules per day. And so this is going to be equal to 8.64 times 10 to the 7th joules per day. Okay, part B. If light energy to electric energy conversion using solar cells is 15% efficient, how many square miles of land must be covered with solar cells to supply electric energy for 250,000 houses? Assume there is no cloud cover. Okay, so we know that there are one house uses 8.64 times 10 to the 7 joules per day, and so it uses 8.64 times 10 to the 7 joules in 1 day. So 250,000 houses. 3 times 8.64 times 10 to the 7th joules is going to be equal to 2.16 times 10 to the 13 joules. So that's the total amount of energy used by 250,000 houses in 1 day. So now we want to know how large an area of land do we have to cover to produce 2.16 times 10 to the 13 joules. And we're told that the light energy that falls on a square meter of ground over a typical sunny day is 20 megajoules. So 20 megajoules is just 20 times 10 to the 6th joules. But we're also told that the solar cells are only 15% efficient. So only 15% of this energy is going to be available per square meter. So this times 0.15 is going to be equal to 3 times 10 to the 6th joules. And so this is going to be how much energy is produced by 1 square meter. And so we know the total amount of energy that needs to be produced and the amount of energy that's produced per meter. And we want to know how many of these square meters do we need to produce this much energy. So all we have to do is divide 2.16 times 10 to the 13th, which is the total energy consumption of 250,000 houses, right? Over 3 times 10 to the 6th joules per meter. And so this is joules as well. And so if you notice, the joules cancel out, and 1 over meters is just meters. So we're in meters, so we're in the correct units. And this comes out to 7.2, this is meters squared, sorry. Joules per meter squared, right? 7.2 times 10 to the 6th meters squared. But in the question, we're asked how many square miles of land. So we have to convert this meters squared over to miles. And so we know that there are 1,609 meters in 1 mile. But we're dealing with square miles and square meters, so we have to square all this. And so our meters squared can cancel out, and we're just left with miles squared. And so this is going to come out to 2.78 miles squared. So to power 250,000 houses with a 15% efficient solar cell, we have to cover 2.78 square miles of land to produce the amount of energy needed. And that's not taking into account cloudy days and all that. And so that's problem 11.68.